Hi, this is Mr. Max with a test here on equations, expressions, identities, and inequalities, algebra, especially when we have a look at absolute value functions and sequences and series. So this test is out of 45 marks, and I gave it to my students not so long ago. I believe that I can also share this with you, and then you can also perhaps go through it as you do revision. I expect in the Rango region, we are following the scheme of work, and this is where more or less the teachers ought to be. Right, let's just delve into it, and you'll see that I have tried to mix up the questions so that I can more or less um, do uh, each of its requirement, or shall I say, or objective that is there. However, I will also suggest that maybe you can also try to do the questions on your own before you have a look and see if your answers matches with mine. Now, you have a function here, ideally 3y squared minus 12y minus 15, and they are expecting you to write it in this form here. And this is something that we call vertex form, right, where the b value tells you the vertical translation, and whatever the value of a is here. So if you were to take the stuff inside here, the y plus a, and you let it equal to 0, it will tell you the horizontal translation of that function, which is parabola. So there are many ways you can do this. Ideally, this is a 2-mark question if you look at it, which means you should not really be struggling to solve this question. So I will use completing the square method. So what I will do is I'll write y equals to 3y squared. In fact, maybe it will be a bit tricky to use this y. So I will just say, uh, let's say f of y, just so that we don't get confused. So this is f of y is equal to 3y squared minus 12y minus 15. The reason I'm doing that is I want to bring that 15 over so that it can be a plus while I am working essentially with the stuff on the right hand side. So I'm going to bring that 15 back later. Okay. So was this, say, for example, a letter x, and I'll just be using y because f of x is equal to y. But since this expression here, or this function has got y in it, so I'm going to say f of y. Anyway, think of this f of y as a placeholder. Now, what I have on the right side, is two terms which we can definitely factorize by removing the 3. So sort of pulling it out there, and 3 goes into 12, obviously 4y. So I'm not taking out the common factor of y there because the value of a, as you can see here, should be 3. So what I'm going to do inside here, the y squared minus 4y, you're going to complete the square. So you're going to take half of the 4, divide it obviously by 2, and we're going to square that. So if you were to do that, you get negative 2. So before I square, or perhaps this is very important that you take note of this. So this minus 2 is going to be what I'm going to put here, y minus 2 all squared. And I'll explain a little bit what I mean by that, okay? Now, the 4, essentially anything that you square, whether it's negative, it's always going to be a positive. So if I was to take this y minus 2 all squared, just say y minus 2 all squared, and I was to multiply this out, it's going to give you y squared minus 4y plus 4. That's what you're going to get. So essentially, as it now appears, is that we have a 4 here that is in here. So in order for us to make sure that this looks exactly like what you have over there, so perhaps maybe I'll just play around, a little bit around. So to make sure that this stuff here, as you can see, this stuff here looks exactly like this stuff here, I will have to do something with that 4. And what I'm doing is I'm going to remove it just so that it can be balanced. So there's a 4 that is in here, so we're going to take away the 4. Now, before I bring my 15 back, I'm going to multiply this 3, very important that you remember this step, with this minus 4. So that this is what I'm going to have now. So now I'm going to have the stuff here, f of y plus 15, this is equal to 3, y minus 2 all squared, but 3 times negative 4 is what? That's negative 12. So now I can actually bring back my 15. So I'll just go ahead and say, okay, I have 3 here, and I have y minus 2 all squared minus 12 minus 15. Essentially, if I have to clean this up, I've got 3 y minus 2 all squared minus 27. And this is the form that they expect the question to be in, right? So A will be minus 2 and B will be minus 27. However, the question was asking for you to write it in this form here, okay? And this is very important that you understand that as the answer that we are looking for in this particular case. Now, there are many ways, again, as I said, that you can do this. Essentially, I just wanted to express that method, which is something that I expect you to be familiar with. You can also go ahead and use the axis of symmetry, which will allow you to find the turning point. Obviously, then you have to take the opposite of that. So just to maybe bring that in there, and let me just add something so you can see what I mean by that. So let me just append the page here. So I'm going to come back obviously to that. So I have the function is 3y squared minus 12y minus 15. So let's just take a different approach perhaps. So let's say we have 3y squared minus 12y minus 15. Of course, I can't say y equals to because the 2 have nothing to do with that. So I'm going to say f of y, right? So what you can do, if you use this formula here, but now the formula naturally is minus b over 2a. This is what we refer to as the axis of symmetry, okay? The axis of symmetry. So if you have a parabola over there, and you were to sort of draw that line over there, okay? It's just a sketch here. That line, that axis of symmetry. So what this allows us to find, we are finding that x value, and then you can find the corresponding y value. So this will be the axis of symmetry because the curve is symmetrical. Now, I'm not going to say x equals to, because my function is not given in terms of x, but in terms of y. So y equals to minus, and I'm going to look at the value of b over 2a. So it's very important that you understand that this is ay squared. I'm going to say plus by plus c. You can see that the a obviously is 3, so go ahead and punch in 3. And then my b value is what? Negative 12. It's very important that you don't think that this negative has got anything to do with that one. So eventually, this is 12 over 6, which gives you 2. So if you were now to rewrite it in that form, where they say the 3 should be outside, obviously you're going to have y. And if this is positive, inside here, you're going to have the opposite, which is going to be minus. So what is now left is for us to find this b here, right? So just important that you know this. This tells us, if you have y equals to 2, that if you had to sketch the parabola, for example, okay, then the parabola, so if I was to say, okay, here is, and this is, again, just take note, it's just a sketch, all right? And if you were now to draw that parabola, is that parabola going to be to the right side? Because I said the stuff inside here represents the horizontal translation to the left, to the right. So if this is minus here, and you take that stuff, you say y minus 2 is equal to 0, you get y is equal to 2. And was this now the x? So that would have been y equals to 2 is on this side. Okay, so let's suppose the 2 is here, right? So it tells me that my graph is going to be more to the right side. So the y-intercept, obviously, as you can see, this graph is going to cut the y-axis at minus 15. So eventually, it's going to go all the way down like that, right? So if I was to sketch, I will know that the graph will be on on the right side. Okay, so this is just, remember, it's just a sketch. Okay, so if this was y equals to -2, then my graph would have been on the other side if I was to sketch it, for example. So that's what this stuff tells us. So what does the b tell us? Well, the value of b tells us the vertical translation. So essentially what I have here, that x value is here, right, on the x-axis, so to speak. So if I want to find the corresponding y value, okay, now I would want to know what point is this on this function. So I would go ahead and say, okay, let me go back and put that value of y equals to 2, essentially this 2, into my function and see what is it that I'm going to get out of it, as so to speak. And if you were to do this, all right, you obviously can use your calculator. So this is 4 times 3, which is 12. And this is minus 24, because you have got 12 times 2 minus 24. And you have minus 15. Of course, go ahead and grab your calculator. You'll see that this answer is minus 27. So that is the value of b. So essentially, I'll just go ahead now and rewrite it as required. It's 3, then you have y minus 2 all squared minus 27, which is a faster way that you can actually calculate or find this without you having to really complete the square. By finding the axis of symmetry, and obviously whatever that axis of symmetry is, if it's a positive value, inside here, inside this stuff where the square is, it's going to be opposite. So if it's a positive here, it's going to be a minus. Had that been a negative, telling my graph is going to the left, okay, then this stuff inside will be plus. So how do you find the vertical translation? You just simply take that value that you got and you substitute it into the original function. All right, so that is in a nutshell that you can do. But I'm going to work with what I have from my previous part, because they are saying hence. So whenever you have got a hence question, it means you are supposed to use what you have in the previous instance in order for you to calculate this. Now I just want to write down a little bit what it was originally. It was 3y squared minus 12y minus 15. Let's suppose that is equal to 0. So this quadratic equation is equivalent to this. This is in, so suppose if it was equal to 0, they will be equivalent. Well, this one will be in vertex form and this one is going to be in standard form. Now here's the thing that I want you to focus on, right? Look at the middle one. Do you see where the x square is and where you have y? That is the middle one. That should be your guiding factor. You can say let y equals to x squared. So everywhere we have an x square in there, I'm going to replace it with my y. Everywhere we have an y here, I'm going to replace it with a x squared. But let me just bring in the original one. So, or the one in vertex almost 3, y minus 2 all squared minus 27. Let's suppose this is equal to 0, because I said that this vertex form and that form is equivalent. Okay, now this is in vertex form, it will be easier for me to calculate this. Now, what did I say? I said, of course, this y should be replaced by x squared. So essentially, what it means, I'm going to replace this y here by x squared, and I'm going to work my way from there. Okay, so if I do that, let me just scroll down for a little bit of space, I'm going to end up with 3 in bracket. Now it's x squared minus 2 all squared minus 27 is equal to 0. This is going to give me x squared minus 2 all squared is equal to 27 divided by 3. That 27 goes over, becomes a positive, and then I eventually divide throughout by 3. This is going to give me x squared minus 2 all squared is equal to 9. Okay, so what we need to do is get rid of the square so that we can have only x squared minus 2 over here. And how you do that is you take the square root, which is a positive and a negative, of 9. So this is eventually going to give you x squared minus 2 is equal to plus or minus 3. So we're getting very close to find our answer, right? So perhaps I should just, because I'm running out of space, I'll just insert a page in here. So I'll just append the page so that we can work our way from there. Okay, all right. So where I am now is I have x squared is equal to plus or minus 3 plus that 2 if you take that 2 over. So that's going to give me x squared is equal to 3 plus 2, or x squared is equal to negative 3 plus 2. Very important, perhaps maybe they just should separate them, and then you'll be able to know which one is it that's going to be valid. In this case, x squared is equal to 5. In this case, x squared will equal to negative 1. Now, here's the problem. If you were to get rid of this square, you have to take the square root, and the square root of a negative number does not exist in the set of real numbers. So this is going to be an invalid. You're going to reject this one. It's not going to work. Right? So what is our solution set then? Our solution set has to be, taking the square root of this side, is going to be positive and negative the square root of 5. All right? Essentially, it means x is equal to the square root of 5, or x is equal to negative square root of 5. That is what it means there. Now, this is very important that you don't grab a calculator, because the question in the stem says, if you go back, it says, and this is very important that you always read, find the exact solutions. Now, you are not going to round this answer, because a rounded answer is not an exact answer. So this answer in third form as it is, this is the exact value. All right, let's go to the next question. The next question is a little bit of work on the binomial theorem. So I picked a question where there is a little bit of a catch here. It says the coefficient of x cubed in the expansion of 3 plus ax all raised to the power of 6 is equal to 160. So what is it that you are being told? Yes, you are being told that the coefficient of that is 160. We don't know which term contains x cubed. Since we don't know that, I'm going to use my general formula. When I'm going to say 6 choose r, because we don't know what r is, and that is going to be, remember, this is 3, so 3 is going to be 6 minus r, and then a over x is going to be to the r power. Now, let me just put, and this is what I will suggest you do. 6 choose whatever r is, this is a constant. And also, this is going to be a constant. If we determine what r is, it's a constant. Then a to the r is also going to be a constant. And then obviously x to the r. Always choose to write this like that. So what does this question say? Now, I just want to emphasize something. Whatever this value is over here, whatever this value is over here, are we together? Up to that a. This is going to be 160. And it's going to be the coefficient of what? Of x cubed. So essentially, let me then say x to the power r should be equal to x cubed, meaning that my r therefore is equal to 3. So if that is the case, I can actually find all of this. All right. So this whole thing, whatever it is, should give me 160. So let me see what is it that I'm getting before I can equate that to 160 by punching in my value of r that I have now determined. So I'm going to have 6 choose r. Now our r is 3. That's a constant that you can calculate, of course, and I hope you know how to calculate that. And if you have to, you can use a calculator, unless you can use the factorial. So you can say 6 factorial all over 6 minus 3 factorial times 3 factorial. Okay, and eventually you can obviously calculate these out. This is going to be the same as 6 times 5 times 4 times 3 factorial divided by, this is 3 factorial over here, and this 3 factorial is nothing but 3 times 2 times 1. Now, let me just show you how you obviously can find that answer. You can cancel out 3 factorial here. This whole thing here, 3 times 2 times 1 is 6. So I can cancel out. So you see, I'm left with 5 times 4, which is 20 over there. However, you can always grab your calculator, so you can see, you can use, you say 6, shift, you use this one here, and choose R, okay? And then for 3, you're going to get the 20 that is there. Okay, right. So that was just to show you how to find it without using, obviously, calculator. So that's what this is. And now what is the next one? The next one is multiply that by 3, 6. But now I'm going to replace that R with our 3. And A cubed, okay? Right. This should equal to, this stuff, as I was saying to you, should equal to 160. That's what it is. All right. So this is 3 cubed. And 3 cubed is 27. A cubed should equal to 160. Again, let me just add a page there. So I will be coming back, obviously, to do part B. Just because of space, I'm just going to insert a page or append a page as it is, just so that you can follow what I'm doing. So again, as I said, I'm going to come back to part B of the question. Right, so now that we have 20 times 27, a cubed is equal to 160. So let's just write that down. So we have 20 times 27 times a cubed, that is equal to 160. This is 540. A cubed is equal to 160. A cubed is equal to 160 divided by 540. Now, if you were to sort of simplify that 16 over 54, this is going to be a cubed is equal to 8 over 27, if you were to use that. And one of the things you should know, you can actually calculate from here already the answer by taking the cube root of both sides. But I'm realizing that 8 is a cube number of 2 and 27 is a cube number of 3, right? And I hope you remember from the laws of indices that if the indices are exactly the same, then the bases are equal. So therefore my value of A is nothing but 2 over 3. Of course, you could calculate that one also by simply going here and saying, wait a minute, A is the cube root of 160 over 540. It will still generate the same answer, okay? All right. So just thought that it was sort of going to be worthwhile for me to show that. So now that we know what the value of A is, so let's go back, and I will be using this space again, because I know that my part B, I will need more space. So remember, A is 2 over 3. So now they are saying, hence find the coefficient of x cubed in that expansion. So let me just bring in, take this this first binomial here, the 3 plus. Remember, our A is 2 over 3 now, x. We're going to raise that to power 6. So let me use the general formula or the general term, where if I want to find the first term, and the first term here would be 6 choose 0, okay, right? And I hope you still remember, because even if you are a little bit forgetful as far as these formulas and stuff is concerned, you would see that as you scroll down or as you work further, that there is a list of formula that is being provided um, within in this. But it's very important that you understand that we have n choose r is going to be equal to, whenever you're dealing with binomial theorem, you're going to have that tr plus 1 term is going to be n choose r, and our a is going to be n minus r. Our b is going to be, excuse me, our b is going to be r. So in this case, this 3 here is my a, and this whole one here is my b term. Okay, so if I have to calculate the first term, I'm going to say, take that 3, raise it to power n minus r, or 6 minus 0, times, well, of course, the second term, 2 over 3 x raised to the power of 0, because these ones have to correspond. This is not really necessary to do, because what you have is 6 choose 0 is 1. 1 times 3 raised to the power of 6. Well, that's a horrible number, but let's find it. What is it? So we're going to say 3 raised to the power of 6. So that's going to be 729. So that's 729. Well, this whole thing becomes times 1. So the first term is 729. Okay? So maybe I should write that down so that you can see. So this one here represents my first term. Right. What is my second term? 6 choose 1. That is going to be 3. Now this is going to be raised to the power of 6 minus 1, which is 5. And then you're going to take the value of b, in this case, which is 2x over 3. That is going to be the power 1. Also, something you should know is that this 2 should give you that value of 6. Right. So this is going to give my second term. 6 choose 1 is just going to be, and very important that you know this, perhaps you might forget 6 choose 1. Okay, that is just going to be 6, Right, so you've got 6 here, multiply that, 3 raised to the power 5, again, 3 raised to the power 5, that is 243, it's 243, then obviously multiply this by 2 over 3, and this will just get that x raised to the power of 1. So if you punch this in, all of this on the calculator, so I'm going to do the numbers, so let me just move the calculator over here. So I've got 6 times 243 times 2, and you divide that answer by 3. Good. That gives you 972. So this is 972x. So this one here becomes my second term. So you can see that the term is x is to the power 1. This is obviously that. So I need to do 2 more of these, at least so I can get to x cubed. Right. So I'm going to have 6 choose 2. Okay. So this is my third term. My third term, R is always 1 less than the term. So the third term is this. Then I'm going to have 3 raised to the power 4. Then this stuff over here, let me just, for the sake of separating it to, this is going to be squared, and that x will also be squared. So I'm just separating the two. So I'm going to punch in the answer without me having to write everything step by step. So we're going to say 6 choose 2. We're going to multiply that by 3 raised to the power of 4. Then we're going to multiply that. Oh, let's go for it. Yeah. Then we're going to multiply that. And bring in my brackets. But as an AS level student, I expect you to see this is 4 over 9. Okay, 2 upon 3. Well, all of this is squared. This is going to give me my constant value over here. You hit enter, that's 540. Okay, so this is 540x squared. Right, I think I should do one more so that I can get there. And one of the things that you will now realize, I don't have to do this here because I already know what a third term is. I know that the third term is 160 x cubed. I know that from our work here before because we had the same thing here. 6 choose 3 times that. This whole thing should be 160. Supposedly, let's do it because now we know what the value of a is. Let us see if we are getting 160 x cubed or 160 as the coefficient there. So we have got 6 choose 3, then this is going to be 3 raised to the power of 6 minus 3, which is 3. Let's take the constants to 2 over 3 raised to that. So these two should be identical because 3 plus 3 should give you that 6. And then obviously x should be cubed. So let's take our calculator again and see what this gives us. And remember I said it should give us 160 because we were told. Now I'm just going to go back, so I'll make this a cube. And I'm going to make this a little 3 over there. And then I'm going to have 6 choose 3 over here. That gives you 160. Can you see that we're on the right path? All right, so this is 160x cubed. Essentially, I have got my third term and my fourth term. So I'm just using this so that I can explain the concept. So this is the third term, and this one over here will be the fourth term. And the reason why I had an end there is I'm going to write those terms down so you can see exactly where I'm going with this. Again, I have to bring in or work from this page. So what was my first term? Let's go back. My first term is 729. Okay, so I'm going to write my first term. So my first term is, so essentially what I have here, this is 3 plus the a was now 2 over 3x all raised to the power of 6 is equal to, first term was 729 plus, what is my second term? My second term is 972x. Just remember that. So I'm going to write that down. 972x. What is my third term? So let's go back and just write down our third term that is there. Our third term is 540x squared. So it's going to be 540. It's 540x squared. Let's just bring in the third one, which is 160x cubed. And so on and so on. Now that I know that, they are asking me to find the coefficient of x cubed in this expansion over here. In this expansion, 3 plus 2 over 3x raised to the power of 6. And the other one is 1 minus 2x. But I'm going to replace these with all of that and see what the x cubed terms will be. So So I'm going to rewrite it where I have the 3 plus 2 raised to the power of 3 x. I'm going to rewrite it with maybe I could take 1 minus 2x right in the front, and then I will have the 729 over here plus 972x over here plus 540x squared plus 160x cubed. I'm just going to end there. Now the reason I'm doing that, I'm trying to see which ones can I multiply over here that will give me 160x. I mean that will give me x cubed. So if you take this one and you multiply this one all the way with this term, it's going to give you 160x cubed. There's nothing else you can multiply 1 with. So if I take this minus 2 and I multiply this minus 2 with this one over here, okay, this is going to give you minus 1080 x cubed. There are no other terms that will multiply that will give me x cubed. So essentially, whatever this answer here, this is going to be my answer. So when I take 160 and I say take away that, I'm going to get minus 920 x cubed. But what is the question is asking us to find? What is the question asking us to find? The question asks us that we need to find the coefficient of x cubed in that expansion. So your answer should not be having that x cubed. So then you can make the deduction and say the coefficient of x cubed is minus 920. That is the solution to that. Right, I took a bit long, but I wanted to hit home and bring the point home so you can understand what is it that you need to do there in order for you to find that solution. And at the same time, you have seen also how I'm using my general formula or my general term, and then I can also be doing each term and then I bring them over here. Then there's also the next question. So I'm just going to go ahead and go all the way to question 3. Now, question 3 is interesting as well because it starts off with APs and GPs. Now, 3A says the first 3 terms of an arithmetic progression, okay, are 25. The second term is 4p minus 1. The third term is 13 minus p. So where p is a constant, so what is it that we know? We know that A represents the first term, that is the letter we use, so first term is 25. What do we need to determine? We know that since it's an arithmetic progression, an AP, that the common difference will naturally be calculated by taking. So the first term, let me just write down so you can get this gist of the matter. This is 25 is the first term. This over here is my second term. This over here is my third term. So for you to find the common difference, you take the second term minus the first term, should be the same as the third term minus the second term. Okay, since I'm minusing or subtracting expressions, I'll be inclined to put brackets. So my first term is 4p minus 1 should equal to the first term, which is 25. Okay, actually, let me just say minus 25, sorry, not equal to. So the first, that term minus 25 should equal to my third term, which is 13, minus p, minus the second term. I'm going to bring brackets in here because I'm subtracting more than one term. Of course, when you clean this up here on this side, you're going to have 4p minus 26. And on this side, you have 13 minus p. Very careful with this minus, that is minus 4p. Now you have a plus 1 there. So let's just clean up what we have over here. So we're going to have 4p minus 26 is equal to, well, 13 plus 1, well, that's 14. Minus p minus 4p, that's minus 5p. When you do all the manipulation, you should find that you have 9p over here. And then you take that 26 to go meet its friend there, it's going to be positive 40. So essentially, p is nothing but 40 upon 9, which I'm going to leave like that. Okay. Now, what is it that we need to determine? We need to determine our d. So let's see what our d value is. Okay. Our d value or the common difference, and I'm just going to use a different color here because we can now actually determine. We can say, okay, so for that method, our D, which you calculate by taking, for example, term 2 minus term 1, which term 2 was, from our work there, was 4p minus 1, which is term 2. This whole thing here represents term 2. If you minus that with the first term, which is 25, okay? So we know that this was 4p minus 26, right? But what is it that we now know? We now know that the value of p is 40 over 9. So minus 26 over there. This is going to help me to calculate the common difference, right? So eventually, if you do a little bit of manipulation there, you will realize that, well, our common difference is nothing but minus 74 over 9. Okay, minus 74 over 9. So that's what D is. Right. What is it the question asks us? So that we now know what is our A. So I'll just bring also our A. So our D is equal to that. We also know that our A is the first term, which is 25. So I have got my A. I have got my D, common difference. But the question is asking us to find the value of the 10th term. So you have to use T sub n. Okay, for you to find this value of the 10th term, you must use T sub n of an AP, which is A plus n minus 1 times D. So we just have to plug in our A and our n for 10 and our D for that value that we got, minus 74 over 9. So the 10th term will be our A, which was 25, plus 10 minus 1 formula times minus 74 over 9. Okay, so you can go ahead and punch this in on the calculator, and you should get to your answer, right? So let's see what it is. Okay, so it's 25 plus, so this is going to be 9, because that's what 10 minus 1 is. I'm going to multiply that by negative 74 upon 9. Okay, good. So those 9s, they cancel there. So I'm going to have 25 minus 74, which is minus 49. So minus 49 would be the 10th term. And that is the required answer. So you get the various marks there, method marks and stuff like that, then A marks, accuracy marks. But that is essentially what is it that you needed to do over there to find the value of the 10th term. You needed to find, A is 25. You had to play around to find the common difference, and then you then go ahead and substitute them into the T sub n formula. All right, the B part is very similar, but this time around, this is a geometric progression. It's a GP. Again, I will identify this is my first term. Just change the letters around so you don't confuse. But essentially, that is the second term, and this over here is the third term. What is it we know? A is 25. It still is the first term. A GP has got what we refer to as a common ratio. Common ratio is calculated by taking, for example, the second term divided by the first term. Should give you exactly the same answer as you take the third term divided by the one preceding it. So this is going to be the second term, which is 4q minus 1. I'm going to put that in brackets, okay? All over the first term, which is 25 over here, should equal to the third term, which is 13 minus q, put that in bracket, all over the second term, which is 4q minus 1. So there's a little bit of cross multiplication. As it is, you're going to have 4q minus 1 squared multiplied by itself should equal to 25 multiplied by 13 minus q. So very important that you had to put those things in brackets there. Otherwise, you would have a problem when you are doing your cross multiplication. Okay, right. So from here, I'll show you an alternative method as well. But let's just, because we have started with this method, let's just continue with it. Just remember that this is a bracket. Okay, it's not a 1. Just make it look a little bit nicer. Okay, so don't worry, we'll have to pause a bit. Okay, so I pressed one of the things that I wasn't supposed to press. I'm going to save. Let's just close it, and we're going to open it up again. Okay, so there's a lot of things going on here. Let's just go back and open using PDF Annotator, which is a software that, of course, you can buy. Let's just restore, see if it takes us back. God knows I'm not going to be happy with all right with starting that whole stuff all over again. So we were since you can see things already disappeared, but let's save it. We already calculated part 1. Okay, part 1 we did, and we know that the arithmetic progression A was equal to 25. We had our D equals to, when we calculated our D, I think it was a horrible number. It was minus 74.9, and then the 10th term was the A, which was 25, plus, then you have obviously 9 times negative 74 over that. Okay, and it was what, minus 49. Okay, 9 comes from 10 minus 1 in the formula. Okay, right, let's just go back then and also start again with this one. So we know, I'm just going to write down, hopefully you can follow. I had, this is my first term over here, and this was my second term over there, and this was my third term. So A is identifiable very easy. A is 25. We also know that this is a GP, as I was saying before. R is calculating by taking term 2, for example. So let's take term 2. And we are going to divide that by term 1. Should give me the same as term 3 divided by term 2, terms that preceded. In this case, I'll suggest that you put these expressions in parentheses, because you are definitely going to do an element of cross multiplication, the second term by the first, then you take the third term, which is 13 minus q, and you divide that by the second term, which was 4q minus 1. All right, then we cross multiply. We have 4q minus 1. This should be all squared, multiplying by itself. Then you have 25 over here, then you have 13 minus q. Right, so eventually we'll be getting a quadratic that we have to go and solve. As I said, we're going to show you an alternative method. Right, you should be very familiar how to square binomials. So for 4q squared, that is 16q squared. 4q times negative 1 times 4q times negative 1. That's essentially going to give you minus 8q, the middle one. And negative 1 times negative 1 will be positive 1. And this side, you have 25 times 13. So 25 times 13, 25 times 10 is 250. 250, 25 times 3 is 75. Whenever you add that, you're going to get 325 minus 25q. Okay, you can obviously use your calculator to do that multiplication. Right, let's just get everything is a quadratic equation, so all quadratic equations should equal to 0. 16q squared minus 8q. Well, let me bring that 25 to come and meet its brother. So that's going to be a plus 25q if it comes over. It's this one over here. And then we're going to go back and say, okay, essentially we've got a color issue now. So we have the plus 1 that was there. And then let's bring that minus 3, that 225. We're going to say, well, go and meet your sibling over there. Of course, it should equal to 0. So let's see if we can clear this up. Eventually, this should give you 16q squared, and 25 minus 8. 25 minus 8 is nothing but 17q, and then this is going to be minus 324. Very horrible thing that you can use the quadratic equation formula, and if you to use the quadratic equation formula or you factorize, you will definitely have to get the answer. So q minus 4 would be in one bracket, the other bracket would be 16q plus 81, again, equals to 0. Remember I said you can obviously use the quadratic equation formula in order for you to solve this. If you do, you will see that q minus 4 will equal to 0, or 16q plus 81 is equal to 0. So here we have one answer, q is equal to 4. Here is this problem of this answer. This q is going to be minus 81. Take it over, divide by 16. Right. This one here is a little bit tricky for me to use. The reason is they give you a hint in the step right there at the beginning, and you should not take these things for granted. The q is a positive constant. So because Q is a positive constant, this is the value of Q that we are looking for. Does that make sense to you? Right. Now that we know what Q is, we can actually use this to find our R. Excuse me. And our R, we calculated, remember, by saying R was the same as taking term 2, we divided by term 1. Now, what is our term 2? If you go back, term 2, let's just go back and write it. Term 2 was 4Q minus 1. Okay, 4Q minus 1. So just write it down there, and that is 4Q minus 1. Now, I know what Q is. Q is equal to 4. So, term 2 would be, so let's find our R by saying 4 times 4 minus 1. I'll divide this over 25. Okay, let's just clean that up. On top, you have 16 minus 1, which is 15, 15 over 25. So, R is 15 over 25, which gives you nothing but, if you simplify, 3 goes there, 5 goes there 3 times, and 5 goes here 5 times. So we have our R now. Our R is 3 over 5, or 0.6. What is it that we have? Let's write down what we have. Very important. We know the first term is 25. We know that R is 3 over 6. Rather, 3 over 5. What are we supposed to calculate? We are supposed to calculate the sum to infinity. The sum to infinity, this is the formula that you have to use. Okay, it's also provided in your formula sheet. Okay, my infinity symbol looks quite a bit horrible there, but just remember, this is infinity. This is infinity. Surely I'm not the only one struggling with that, but you get used to it as you do these things more and more. Right. Why am I using that? Because they are clearly asking me to find the sum to infinity of the progression. Now let's find it. It's just a matter of punching in the stuff and adding it. So the sum to infinity will be 25 for my A all over 1 minus my R which is what? 3 over 5. Grab the calculator and let's see what is it that we are getting. 25 all over. Well, 1 minus 3 over 5 is nothing but 2 over 5. 1 minus 3 over 5. Okay. Hit equal to 125 over 2. 62.5. 62.5. That is the answer. And then we have that as it is. All right, let's just save that so that we don't have problems as we go down the line. Oh, I wanted to show you the alternative method. Right, the alternative method. It's going to take a little bit of knowledge, but it's always nice if you have. I'm going to work with my R. So my formula, my sequence was 25. That was the first term. The second term was 4Q minus 1. My third term, if you remember very well, was 13 minus Q. Term 1, term 2, term 3. Okay, starting to rain, but let's hope the sound will be fine. What is it that I am doing over here? Let me just go ahead and put this in brackets over there. So now it's very important that we know from our value before. Let me just maybe use that. From what we have calculated, we know that Q was nothing but 4 from the work before. I'm just using that answer to emphasize this point, okay, from the other method. Okay, but I'm not saying that's what you're going to do here. I just want to see what are the terms so you can see exactly what is it, where my thinking is taking me. So this is 4 times 4 minus 1. This will be 13 minus 4. So the first term will be 25. The second term will be 15 because that's 16 minus 1. Okay, 16 minus 1, well, that's 15. The third one will be 13 minus 3 is 10 minus 1 is 9. This is what the sequence or the terms would look like. What is something else? We know from our work before that our r was nothing but take the second by the first, should be the third by the second, which we determined is nothing but 3 over 5. Here is where I'm going with this, so you can understand. If you multiply this term by that ratio, you get the next one. If you multiply this term to go from 25 to 9, okay, let's see, from 15 to 9, you will be multiplied again by that. So let's take the calculator for those of us who need convincing. We have 25 times the common ratio of 3 over 5, that is going to give me 15, times the common ratio of 3 over 5 again, that's going to give me 9. What is it that I must do to go from 25 here all the way to 9, for example? Yes, you have it. I must multiply by that ratio, but squared. I must multiply times 3 over 5 squared. And you will see that if I have to go 25 multiplied by, of course, let's put it in brackets. We have 3 here. Okay, put 5 here. Close that. Square. It's going to give me 9. And so it will be, if I find the fourth one, I'll cube. Right. So my reasoning is, when I'm writing it like this, to go from here to there, I'll multiply 25 by r. That will give me this term. Okay, so let me just write it down. 25 times r will give me 4q minus 1. What is the next one? If I go from 25 to the third one, I'll be saying 25 times r cubed. No, my goodness gracious, r squared, to make the point. R squared should give me the third term, which happens to be 13 minus q. This is where I wanted to bring in the alternative method. Now, what is it that I'm going to do? Essentially, I've got two equations here. Okay, this is my first equation as it is, and this would be my second equation as it is. Now, how do you go ahead and solve these two equations? There are many ways you can solve it. I'll come to this equation here, and I'm going to make q the subject of the formula. Okay, so basically I move the q, and if I do that, or even if I was to make the subject of formula for that one there, still the same thing. But let's make q the subject formula here. So this is going to be q equals to, moving it there, 13 minus 25 r squared. This is q, okay? Moving the terms around, that's what I'm going to get. And I'm going to sub into equation A for q. Could also have made the other one the subject of the formula, doesn't matter. Right, let's see what is it that we are going to get. So we're going to have 25r is equal to 4, but now q is 13 minus 25r squared. Okay, that's what it is. 4 times it minus 1. So eventually we're going to have a quadratic in terms of r. That gives me my r. Because I know what my a is, for me it's just to find r. And then very important that I must understand something. It's a quadratic, so there will only be two solutions for r. And it implies that I must take one and not the other. Okay, right, so what is it that we have now? We have 25r, so a little bit of manipulation. So when you have 4 times that, is 40 plus 12, well, that's 52. And that is 100 r squared minus 1. Okay, so if you were to clean this up, on the right side, I'm going to have 52 minus 1, well, that's 51, minus 100r squared is equal to 25r. Then move everything to the left so that everything is equal to 0. Okay, so let me just, because of the space, and I don't want to bring so many pages in. Okay, this is going to be 100 r squared, good, plus 25r, that one is not moving, it stays there, minus 51, well, that gives you 0. Right, so you can go ahead and use the quadratic equation formula in order for you to calculate that. Now, here's the thing. Let's suppose we do that and we have 5r minus 3, and then here you will have 20r plus 17. Of course, I factorize it, but you can use the formula. Okay, you will see that r here, 5r minus 3 is equal to naught, or 20r plus 17 is equal to naught. Now let's go ahead then and say, okay, wait a minute. You're going to have r is equal to 3 over 5. Or if we make r the subject here, r is going to negative 17 over 20. Okay. Right. Let's go back. We have got two values of r. Which one are we going to consider? Well, remember, you have to be very careful here that there's that one that you shouldn't consider, the negative one. Because we know that our q from before, we were told that q is a positive constant. So if I have to take you back to where we calculated q, what is it that we were doing to find q? We calculated q, and we knew that q must be a positive thing, such that when we are punching it in there to find our r, it gave us a positive answer. So we are going to consider the positive r value. Okay. What if a student, okay, now that I'm here, we have got the sum to infinity will be that 25, then you have 1 minus, of course, that answer, which will give us exactly the 125 over 2, which I think is half of that is 60.5, which is the correct answer. So what if a student is stubborn and the student say, wait a minute, a is 25, but I want to use 1 minus negative 17 over 20. Okay, using the other r value. Just want to see for interesting purposes, although that we know we should not use it. So it's 25, and then you have what, 1. Essentially, that becomes a plus, the two minuses here. Okay, but I'm going to have it minus in bracket minus 17 over 20. Okay, and then close it, and then you're going to get a horrible number there, but that is not the number that we were looking for. Okay, it doesn't get closer and closer to that. Okay, because again, we had to consider the positive value of r. So this one will not be used. All right. So I'm not even gonna bother with calculating it. So it's very important that you read the stem of the question and you understand the instructions as they appear, and why is it that you're supposed to use which particular value as it is. Very important. So that was an alternative method that I use, and I know that r has to be also a positive one because the terms are, as you can see, it's going to be positive, and it's going to get closer to. Here's another thing why r will not be negative. Because the moment you have got a negative ratio, in that case, our terms is going to oscillate between positive and negative, positive, negative. Although we can see that it also will tend to a number. Okay, but here they say q is a positive constant. So because it's a positive constant, you have to do that manipulation to determine that I must reject the one here. So here I rejected the negative value of q, which was the negative 81 over 16. So I rejected that value. So naturally, I must also know that I must use the positive value of r. It's an alternate method. Right, question 4. We're very close to the end. Consider the following geometric series for which the values of x will converge. Now, for GPs to converge, they have to have a specific determination, and that is that the R, the common ratio, the absolute value should be less than 1. So I hope by this time you have done the algebra for you to understand. If I was to say to you, just as a matter of fact, sketch this graph, the absolute value of x is less than 1. How would you sketch such a graph? Okay, and you might have a problem, but it's not a difficult thing for you to consider. Okay, now let's have that arrow pointing the other way around. So I'm gonna have that over here. I'm gonna have that over there. Right. So let's say we are going to sketch this graph. Now, one of the things that you're gonna sketch, of course, there's nothing there that happens. So this graph is going to be you know, it's either, let's say, it's either going to go from here. Let's just use a different color, perhaps. It's going to go from here and here. This is the graph of let's have it. The graph of y equals to the absolute value of x. This is the parent graph. We expect you to know this graph. Okay. Think of it as drawing the line y equals to x, which is this line here. And then also think of it as the drawing the line y equals to minus x, which is the line that goes here, essentially. Okay. So what does it mean for values as less than -1? So suppose I have a line over here, and I bring that line here. Okay. Just have that line and have it maybe a different color. So suppose I have that line here. And let's say for arguments purposes, this line is y equals to 1. That's what that line is. Values of x that are less than 1, as we have it here, would be the values that are below. That's the values of x, less than 1. Now remember the graph of y equals to x. If this is 1, that is also 1. If this is -1 over here, that is also going to be 1. Okay, so that's what we're looking for. So what does that say to me? It says that the way you'll be solving this absolute value, it's going to be a value that is between 1 and -1. And it's this determination that we are going to use. If we have r, so that means the absolute value of r, for it to be less than 1, should be, our common ratio should be, by that understanding, should be between 1 and -1. But now, going back to my series, you can easily see that the common ratio has to be this 3x here plus 1. That's the common ratio, because it's the one that is doing something to that 5s and so on. So, having identified that, knowing now, wait a minute, but r is equal to 3x, is it, plus 1. So the only thing that you need to do is put this r between those extremes. So you would be expecting to say 3x plus 1 is less than 1, greater than or equal to -1. Essentially, you make that x to be on its own. Okay? So from here, I'm going to have taking -1 from both sides, subtracting 1 here, subtracting 1 here, subtracting 1 here. I'm going to have -2, 3x less than 0. Then, what is the next step? Of course, the next step is I'm going to divide here by 3, here by 3, and here by 3. So my final answer, if I have to write it here, will be x is less than 0 or x is greater than -2/3. This is what we're looking for here. To find that determination, you have to use that consideration that the absolute value of r should be between 1 and -1. Once you have that, you have no problem in determining our final answer. So this over here will be the set values where our x would be in. Okay, so that's the reason I made it 2 marks, because there was nothing really that you needed to do there for you to go and sort of do a lot of calculations and so on. I just had to bring this in, taking you back on our work of absolute value, which there is a question that is coming that you will see. Right, so what is it that they are now telling us? So let's just write down from our previous work, our A, our first term. Our first term is 5, and in bracket is 3x plus 1. Okay, so our first term is 5, in brackets 3x plus 1. But what do we know? We know that x is -1/6 plus 1. So we can actually calculate what our first term would be. So let's go ahead and say 5. Then we have 3, and then we have -1/6. Okay, so that's going to be -1/2. Then you add 1 over there. Let's close that again. So we're going to have 5 over 2 or 2.5 as it is. Okay, so this is 2.5, which is our first term. What else do we know? We know that r was 3x plus 1. But then they are saying to us x is equal to negative 1 over 6. So therefore, we're going to have 3 negative 1 over 6 plus 1. So of course, this is negative a half plus 1. It's just going to be a half. Okay. Now we know what our E is. Now we know what our R is. We're going to find the sum to infinity. So the sum to infinity will be our value of A, which is 2.5 over 1 minus half. Okay. Let's grab a calculator and see what it gives us. I think it should give us a value of close to 5. Let's see. So it's 2.5 all over 1 minus a half is just a half. See, very easy. 1 minus a half is a half. Good. A half. There you go. Our answer is 5, which is the final solution to that question. Sum to infinity. Okay. Little 3 marks that I added in there just to see if you're substituting correctly using the correct formula and stuff like that. Okay, let's go to question 5. There was, hopefully is, another question. Okay, good. Well, you can pause the video because it's quite a lot. As I said, this is a 45 mark test that I gave and to the kids just for them to catch up on it. Okay, right. So that takes me to question 5, given that you have got the, so this is sigma notation here. And the moment you see this funny looking Greek letter sigma here, you must always think of sum. And the moment when you realize that there is a power involved in the summand in the formula, okay, this is going to probably be a GP, but you have to test whether it's a GP or an AP. So we're going to do that. Let's see what is my first term. It's going to be 2 times 3, but now k is 1. So it's 6. What is my second term going to be? It's 2 times 3 squared. So that's 9 times 2, 18. Okay. Third term, what is it going to be? 2 times 3 cubed. Okay. That is 2 times 27. That is 27 times 2. It's 54. Okay. Naturally, this can't be an AP because 18 minus 6 is not the same as 54 minus 18. So this is a GP with a first term equals to 6. And our R will be 18 divided by 6, which is the same as 54 divided by 18. R is equal to 3. Okay. So we know this is a GP. We also know from our work here, we know that the S sub n is equal to this rather horrible number, 43,046,718. That's what we have. So what is it that we're going to use? Well, let's use our S sub n formula. And what is our S sub n formula, if you remember? Our S sub n formula is going to be A here, 1 minus r to the n, all over 1 minus r. I suggest you just stick with this one. I keep on telling my students that I know that some people are saying if r is less than whatever, use the other one. But I hope you can see the closeness that this particular formula has with the sum to infinity formula. So I'd rather say stick with one thing so that you don't make a mistake. Eventually you get the same answer. Okay. Right. What is A? A is 6. 1. What is our r? R is 3 to the n is what we are required to find. And that will be 1 minus 3 is equal to that horrible number, 43 million. Okay, remember from our previous work there. 46,718. Do a little bit of manipulation here. Now, if you were to do this, 1 minus 3 is negative 2. The negative 2 into 6 is negative 3. So I'm going to do this. 1 minus 3 to the n is equal to that horrible number. Okay. Then what is it that I need to do? I need to get rid of that negative 3 by dividing throughout by negative 3. So that's going to be 1 minus 3 raised to the power n is equal to this number over here. Let's bring in, okay, divided by negative 3. Okay, what does that leave me with? Of course, it's going to leave me with a negative number. So I've got 1 minus 3 to the n is equal to, anytime that you are supposed to calculate the value of n, and n is the power, you'll probably have to use indices or logarithms. Okay, something that you just have to know. So this is going to be negative if you divide that positive by that negative. So it's 14 million. Let's see. If you grab the calculator, so we've got a 43,046,718. We divide that by negative 3. 14 million, yeah, 40 million, 348,906. 348,906. Good. We're going to get rid of that 1 here. So I'm going to have minus 3n is equal to this horrible number, 906. And I'm going to minus 1 because of that positive 1 there. Okay. Minus 1 is just going to make that 6 or 7. So don't be too much afraid of that. Okay. So I've got a negative 3 to the n equals to minus 14,348,907. Here's the next thing that a hint I can give you. You have a negative here, you have a negative there. Just stop them. Let the things be positive. Okay, good. For all good measures, don't start there and get bogged down in details. So this 3 to the n is equal to 14,348,907. Another thing worth remembering, okay, n should be, in this case, a whole number, right? A whole number of terms, number of things there. Here is something else. Let's take and see whether this number cannot be written as a power of 3. Okay, you have the calculator. If not, you have to use logs or something like that. So 14,348,907. Hit equal to. Say shift. You go to where it says fact. There we go. So we have got 3 raised to the power 15. Okay, 3 raised to the power 15. Remember that fact. All right. So this is 3 to the n is equal to 3 raised to the power 15. If the bases are the same, then the indices, the exponents are equal. Okay, therefore, n is equal to 15. And that, ladies and gentlemen, is the solution to this problem. Let's save it. Good. So they say find the value of n. We have found the value of n. Okay, step by step, little by little, and then you should get it. All right. Hopefully you didn't forget how I got to this negative 3 here. I took this answer, which is negative 2. I divided into that answer. Okay. All right. So clearing the denominator as it is. Okay. Let's go to question 6. I can make this a bit smaller or a bit bigger. So you have the polynomial p of x is defined by ax cubed bx squared minus 7x minus 8. Now, when you are told that something is a factor, you take that x plus 2, you let it equal to 0, then x is equal to negative 2 because it's a factor. So putting that negative 2 in there, think of it as where will it cut if it was to cut the, the x's. When it's a cubic function, you will be cutting the x's over there. Maybe I will go ahead and I'll draw it. When something is a factor, okay, it means you can find the root, you can find the solution. The solution happens where this whole thing is equal to 0. And this is a cubic function, so naturally it's going to go in this direction, depending obviously what the value of a is. If a is positive, that's how it's going to be. If a was negative, it's going to go the other way around, and so on. Okay, maybe I will do that also just to assist you with that. So that is p of negative 2 is going to give you 0 if you put negative 2 into the function. So everywhere where you have an x, you replace it by negative 2. Okay, in order for us to know that, wait a minute, if I do that, I'm going to get 0 as an answer. So let me go ahead and clean this up and see. This is negative 8, A. This is positive 4, B. Anything squared is always positive. Negative times negative is positive. That is 17 times 2 is 34. Minus A is equal to 0. My formula is getting there, it's getting there, it's getting there. Let's see, what is it that I have? I have minus 8A minus A, that's minus 9A. Then I have what? Plus 4b. Okay, so plus 4b. Let me take that constant back and I'll say that is my first equation. All right. So take note. So when it says something is a factor, you must always it should be equal to 0. All right. So let me just box that in so that we know I'm going to come back and use this one. Good, let's go back. Right, what is the next thing? The next thing says that if it is divided by x minus 2, so it's x minus 2 again equals to 0, this implies that x is equal to 2. So we are going to put, everywhere we have an x, we're going to put a 2. So p of 2 should give you an outcome of 28. Okay, so everywhere we have an x, we're going to put a positive 2 now. Minus 17 times 2 minus a. This is important. It should equal to what? It should equal to 28 because there's a remainder. Okay, let's clean up this one and see what is going to be our next equation. So that is 8a, that's 2 cubed, plus 4b, that's 2 squared plus b, minus 17, so this is minus 34. Okay, just make sure that you don't get confused here. Minus a is equal to 28. Okay, so 28 and 34 must go in mid. And the 8a minus a gives you 7a's. The b is going to be b for b. And you have got 28 here plus 34. 28, that's 50 plus 12. 50 plus 12 is 62. Okay? All right, so we have got 7a plus 4b is equal to 50 plus 12. 8 plus 4 is 12. Let's say that is 62. And that is our second equation. Okay. Now, once we have formed this pair of equations, we are going to solve them simultaneously. Okay, and by now you should have no problem in this type of work. This is ordinary level mathematics. Okay, well, essentially looking for a and b. So the moment you're looking for that, there's two equations that need to be formed, and you solve them simultaneously. So what will I say? I would say I'll take equation b, and I will minus equation a from it. Okay, so equation b, there are many ways. I'm just using the method of elimination because I see that those four b's will do something to each other. So that is 7a plus 4b, which is equal to 62. And I'm going to subtract equation a. What is equation a again? Let's go back. It's 9 minus 9a plus 4b. Okay, there we go. Minus 9a plus 4b, which is equal to, okay, let's go back. That one is equal to minus something, minus 34. It was minus 34. Here we go. Minus 34. Minus 34. Minus 34. Okay. So when you are subtracting here, these two becomes a plus, so this is going to be the same. Let's just bring a line there so we can make our division quite nicely. Okay, so this is going to be 16a. All right, very importantly, you know that this is going to eliminate 4b minus 4b is nothing. Okay, now 62 minus 34, that's 62 minus negative 34, that's the same as 62 plus 34, that's 90 plus 6 is 96. That's 96 over here. So we can actually calculate the value of a by dividing 96 by that. So a is 96, okay, this is a 9, divided by 16, okay, 96 divided by 16, well, that is 6. Okay, very importantly, just write this nicely so that you don't say, I don't know, that doesn't look like a 9. Oh, it looks like a 9, okay? All right, 16 by 96 by 16, 96 divided, okay, 96 divided by 16, of course, that is 6. Okay, good, so our value of A is 6. Now we need to find our value of B. Now I'm running a little bit of, I've got space, I've got space, I've got space, I've got space. Right, so let's take either equation A or equation B in order for us to find the value of B. So let's just use 7a plus 4b, that one that we have, okay? From equation B, which is 7a plus 4b, which was equal to 62. Now that we know that a is equal to 6 plus 4b should be 62. Now we can calculate that value there. 62 minus 42 is 20. B is going to be 5. Let us see. So that is 42 over here plus 4b equals 62. 4b is equal to 62. Take away 42. that is 20. And you have got 4b is equal to 20. Now b would be 20 divided by 4, okay, which happens to be 5. Right, so we can therefore conclude and say, okay, wait a minute, therefore, A is equal to 6 and B is equal to 5. And we have solved our little mystery. I will encourage you to always show the examiner your final answer, as I do here. It's a standard that we use, across the world. You have to bring in or show where the solutions are, so that the examiner doesn't have to go through your work and try to figure out where is what and so on. So it's a maze out here, you know. Another thing for those of you, you will probably see that these question papers, as you have them, they have got the sort of additional pages attached to it, blank pages where you can continue with work or questions that you might not, could not fit there. But I think the work has been worked in such a way that it fits. Here we go. We have got an absolute value graph, a function, y equals to the absolute value of 3x minus 5, and then you have got y equals to x plus 2. One of the most important things when it comes to sketching things on the same axis, okay, let's just go ahead and label them. This is going to be the x-axis over here, and this is going to be the y-axis over there. Is always work and find the intercepts. Okay, and the y-intercept takes place where x is equal to 0, and the x-intercept takes place where y is equal to 0. Very important. So let me take the graph y equals to the absolute value of 3x minus 5. If I want to find the y-intercept, I'm going to make x 0. So y-intercept will be 3 times 0 minus 5. Okay, are we together so far? This is giving me y equals to the absolute value of negative 5, and then that's like distance, so the answer is 5. So this graph is going to cut somewhere at 5. Is it clear? Right. Don't have to put it now, but I'm just showing it cannot go down, it has to come up here. Right. What else do I need to find? Now that I know what the x-intercept is, where I made y0, the x-intercept, let's see what is the y-intercept rather. I made x0. What would be the x-intercept? Where is this graph going to intersect? But touch, because it's not going to intersect, because it can't be, you can't have a value of, this is 0 here. These values will be negative, okay? So you can't have an absolute value function that is equal to some negative value of y. It's not possible. So this graph, wherever it's going to touch the x, is going to reflect backwards. That's what's going to happen there. But let us see if we just quickly calculate it. By making, because we want to find where it will touch, by making our y to be 0, okay? So I'll get rid of all of that. So let's say, where is it going to be? So if you have the absolute value of 3x minus 5 is equal to 0, there's only one solution. And absolute value equation is equal to 0, there's only one solution. So this is 3x minus 5 is equal to naught. Essentially take the stuff inside the absolute value function, let it equal to 0, okay? And then you solve. Of course, if you do that, you're going to get x is equals to 5 over 3. 5 goes over 5 over 3 is like 1.66666. And I expect 1.66666 to be on the right side. It's going to be somewhere here. So I can actually start graphing this. I'll say, oh, wait a minute. It's going to go so, and its reflection. That's it. What are the points? This is 5. This is 5 over 3. Please record so you can know where those values are coming from, because I want to do the same for the y. Oh no, for the straight line, because they say the straight line is x equals to, or let's see, we can bundle it in somewhere here with a different color. I know it's messy, but just try to follow. This equation is easy to draw. It will cut the y-axis at 2, so 2 will be somewhere here, let's suppose, it will be below that. Because if you make x 0, then your y is equal to 2. When you make y 0, then it cuts the x-axis at negative 2. So negative 2 will somewhere be here. Let's suppose negative 2 is somewhere here. And 2 positive is somewhere there. That's where that graph is going to be. So if I was to draw it, and let's say we use a different color just to differentiate the two functions from each other. Let's use this fun color. That line is going to be something like so, just to give you a hint. Good. So that line is a straight line. Okay. I think we have sketched it and we have labeled what we needed to label. So this is the graph, the absolute value graph of y equals to 3x, y equals to the absolute value of 3x minus 5. This one is y equals to now x plus 2 as it is. Can you see that it's going to cut it in two places? It's very important that you do understand that, because we're going to use that information. Because at part B they will say, you must solve the equation where take the absolute value of 3x minus 5 is equal to x plus 2. That means we need to find where they intersect. And this is very important. But I also think I've done it, so let's go to part B. So I have put it here according to scale, and as you can see, they are there. How do you solve this? Now, I want to work from the sketch, and I want you to see something when we work from that sketch, okay? I want you to see something. So let's say we take this, and let me just make it a bit bigger for you to understand where I'm going with this. If you look at this line, can you see the gradient of this line is negative? So I'm going to take that 3x minus 5, all of that, and I'm going to put a minus because that line goes in a negative direction. And it should equal to this black line, the y equals x plus 2. That line is always going to be positive gradient. That's one. Okay? For me to find where I've indicated what would be the x value there of a, because we are looking for the solution to that. Okay, so this becomes minus 3x minus plus 5 now, because it's a negative and a negative, equals to x plus 2. Well, you have got 4x equals to 5 take away 2, which is 3. Okay, if you move our terms around. So x would be 3 divided by 4. So you can see it's very close to 1. So x is equal to 0.75. That's what it means. Okay, so that's one solution. Now let's look at that pink graph again. So can you see that if that was a line, that line would be having a positive gradient of 3x minus 5. And if it was to go down, it will cut at minus 5. Okay, right. So let that equal to the other line, because at this point B, the two functions are equal, x plus 2. So we have got to have two solutions. Okay, we have to have this solution here, and another one that we can see from the graph. You can see that there should be two solutions. Right. And you clearing this out is going to be 2x equals to 7. Essentially, x is equal to half of 7, which is 3.5. So you can see where 3 is, and you can really see, yeah. This is very close to 3.5. That's basically what we are talking about when we are saying this value. So, another solution, x is equal to 3.5. There we go. And we have solved that. So the graph assists you a lot. And by the way, it's also going to assist you, especially if this was an inequality. If there was an inequality where they say one function is less than the other, then you'll be using this graph. So if there was a less than, so you'll be now looking at where is the absolute value graph below that line, and that will be giving that answer in terms of those set range of values there. Okay, so maybe I should mention this just so you understand what is it that I mean using the graph and why using the graph is such a powerful tool. So let's just append the page, although it's not part of the question. It's really helpful. So suppose we had the absolute value of 3x minus 5 So suppose we had something like this. Suppose we had 3x minus 5. Let's say it's less than x plus 2. Now we know the solutions. We have done the solutions. Sort of, we're finding those critical points. You understand what I mean? We know what the solutions are. The solutions is where you have x is equal to 3.5 or x is equal to, from our previous work, okay, what was the other one? 0.75, okay, 0.75. Now, because our graph, let's just bring it. Let's say, okay, let's take our graph. Let's say I bring it over here so I can just make my point a bit clearer. If that is the case, we have these solutions. These solutions essentially occur here at A and B. What does less than mean? It means where is the absolute value below the straight line? It will be below in this range of values. So you would be saying, wait a minute, the absolute value, this happens where x, for values of x, okay, for values of x that is between 3.5 and 0.75. That's how you would be solving that. It's an end inequality, so to speak. Okay, the graphs helps you a lot. Right, what else? So what happens if you had something like so, for example? What if you had the absolute value of 3x minus 5 is greater than x plus 2? Well, of course, this just means you still know your intercepts, as you can see. You just now know where is the absolute value, the pink one, where is it above? It is above where x is greater than, what is it, 3.5. So it becomes an or inequality. Okay, when I come to this other side at A, where x is what, less than 0.75. That's how you would be solving using obviously the inequalities and using the graph. So what I'm saying is it's very powerful to use the graph and to sketch, and you should not have a problem sketching. Whenever you are sketching, remember the key points. You find the intercepts. Okay, make one equal to 0, the other one, you get the other one. So if y is 0, that gives you x. If x is 0, that gives you y. Okay, and once you have that, you can quickly determine and solve quadratic inequalities, where we say for less than inequalities is a sort of an and inequalities, where you have a set of values between a range, and then this one, other one here is all inequalities. Okay, whenever you are dealing with that. So you don't have to go and memorize formula and so on. The graph, the sketch will help you a lot whenever you're sitting with questions that deals with absolute value functions or inequalities as they are. Okay, and then the other stuff, if you have got an absolute value equals to another absolute value, or the other things you need to isolate the absolute values, you then go square and you find those solutions. Square, find those solutions. Is the safe side to square both sides. Okay. All right. Let's come to question 8. When you're told the line does not meet the curve, the keywords there, does not meet the curve, you should immediately think of the determinant here. We are not asking you to solve any equation. So if it doesn't meet the determinant, which is b squared minus 4ac, okay, the determinant will be less than 0 because it doesn't meet. That's one. So for me, I'll be creating an inequality and I have to find that. Next thing is equate the two functions. So x squared minus 2x plus 20, that is equal to cx plus 4. Of course, c is a constant. Move it around so that x squared minus 2x, let's bring its friend, which is minus cx, okay, plus 20. Let's bring its friend, which is going to be minus 4. Okay, I'm just going to say equals to 0. I'm not going to use the inequality for now. Okay, or that is going to be inequalities coming afterwards. So let me just clear this out. This is x squared. I'm going to have minus 2 minus plus c, and my x outside plus 16. There's a reason. Here's something you need to understand. Of course, I could have written minus 2 minus c. But if I have to take b and I square, so if I say minus 2 minus c, anything squared, this outcome will be positive. Everything will be positive. This is exactly the same as saying 2 plus c all squared. You're going to get the same answer. You can try it. Go ahead and see. Okay. So now I can determine what my b is. So I can go ahead and say, wait a minute. B is going to be 2 plus c squared minus 4 times a. Our a is 1 times 16. See, that is equal to 0 for now. Okay. The reason I'm saying is equal to 0, I'm going to look for what is called critical values, the CVs. But what do I know? I know that if this is a parabola, and this is how it will be looking when you sketch it. Oh my goodness gracious. All right, let's just go back and sketch it again. So let's not judge other sketches, but like to have something like that. Okay, so that's how the parabola will be, for example. So for a less than inequality, okay, so essentially, maybe I should come back here before I show you the critical values. Let me make that an inequality. So this is going to be 4 plus 2c plus c squared if you square this. Just for some of you who might probably not see that, even if I was to put this minus and minus, okay, I would be having minus 2 minus c minus 2 minus c. And negative times a negative is positive. Negative times that is positive 2c. Negative times that, positive 2c. Negative times negative plus c squared. So that is going to give you the same outcome as I have here. Anyway, doesn't matter. You get the idea. 4 times 16 is 64. Okay. Let's say it's less than. That's the inequality again. Less than. So let's just simplify. So I can show you why is it that I was saying equal to 0. Okay. So I've got c squared plus 2c minus 60. I hope you get that. Because it's less than, the solution of what we are looking for is going to be below the x-axis. So if this is the x-axis, the solutions are below. So it is this. So once we can determine what is our critical points here, right? These critical points, if we can find them, we can only find them. Then we know, okay, my solution will be C is between extremes, whatever that extreme is, B here, whatever that extreme is, A here. So it's what I expect as an answer. But in order for me to find what that answer is, I'll take this quadratic and I make it an equation. So I'll be saying c squared plus 2c minus 60 is equal to 0. This is helping me to find those critical points, A and B there. But I know my solution is a set of values because there's an inequality involved here. Okay, right. So, well, this should be factorizing very easily for you. If you look at 60, right? 60 is 10 times 6. Are you getting something there? 12 times 5. Are you getting something there? So there should be another one. This is very straightforward. Looking at the contribution of 60, 10 times 6. 10 times 6. I have a little issue that I have to correct here. This 2c and 2c, this is going to be a plus 4c. Apologies. So this here should be a plus 4c. So always make sure, okay, it's plus 4c. This one as well. Okay, the video has been too long. So yeah, my numbers are 10 and 60. The only way you can get a 4. Okay, so c minus c plus, and that's equal to 0. So it's 10, positive 10, negative 6. Okay, I can actually calculate my values now. If I let everything equal to 0, c minus 6 is equal to naught, or c plus 10 is equal to naught, c equals to 6, which is what that b value would be, or c equals to negative 10, which is what that a value would be. So therefore my solution Therefore, my solution will be C. Okay, okay. That's C. It's very sharp. Will be C is less than 6, greater than -10. There we go. We have solved the question. Very important that we understand the issue of the discriminant. Okay. Right. Let's go to our very last question. As you see, it's 45 marks. Right. So you have got some sigma here. You have got a limits of summation from n is equal to 6 up to n is equal to 40. Then you have the summand or the formula to n minus 5. We're not asking you to find the value here. That's not what we're asking. We just simply ask you to find a number of terms if you were to, add all of these terms together. If n is 6, n is 7, n is until you get to 40. How many terms will that be? Everywhere you substitute n to be 6, you work it out. That will be the first term there from 6. If n is 7, what is the value? And so on. Up to n is 40. How many terms would you be doing there? You find it simply by saying 40 minus 6 plus 1, which is included as you are counting, and the answer is 35 terms. That's it. Your work there is fine. So remember that plus 1 because of the inclusivity of counting that 40th in there. And that is all. Right. I have under here, as I said, if I make this test available to some of you on the different platforms, like my Google Classroom, and then at least you have got additional pages. And then also I have included a list of formula notation for the very topic that you are expected to be at, just for you to be able to use that, okay, and how it becomes relevant. Another thing also worth noting is that as you are working to your AS level, and we have done this and said this also when we had some workshops, that the list of formula and notations that are used in AS level, just uh, type them out or take the ones that the kids definitely use, laminate them, let the kids have it with them. So every time when you give tests and so on, then you don't have to, put all the formulas and stuff again there. But it's very important to note that you must go through this stuff with the kids so that they can understand how to find. So if you were to calculate something like 5 choose 3, the formula is right there. 5 factorial over, of course, here is 3 factorial and then 5 minus 3 factorial, which is something that can be calculated. 5 factorial is the same as 5 times 4 times 3. I will not go further. And I have 3 factorial here times, this is also another 3 times 3 times 2 times 1. Of course, these 3 factorials, they can cancel each other. Very important. This 3 factorial cancel here, cancel here. Then 2 goes in itself once, 2 goes there 2 times. 5 times 2 is 10. 10 divided by 3. And that is the answer. 10 over 3. Or 3 and a third. You can see. Let us see if I did not make a mistake there. 5 times 3 is 5 times 4. I did. Yeah, I hope you can see where my mistake is. 5 minus 3 is not 3, but it is 2 factorial. Good. So we need to take away this little one here. So that will be 2 factorial, 2 times 1. Good. 3 factorial cancel. 2 goes there. Again, 2 goes there. 2 times 5 times 2. The answer is 10. The answer is 10. And you can use a calculator, of course, to just make sure that you get the same answer. 5 choose 3. 5 choose 3. And 5, choose, 3. Okay, get 10. Okay. So once they have formula that they can use and so on, even when you come to this one, right? You explain it to them as we are working with the stuff, especially with the sum to infinity formula and the absolute value of r should be less than 1. This simply means, and you have to explain to them, this simply means that r should be between 1 and -1 for it to be a geometric series. Because the only time that you find something that converges, as you are adding the terms, get very close and closer to a certain number, is when r is a fraction, a number that is between -1 and 1. That's what that part means. Okay, and the other formulas are from stuff that they have from a ordinary level and so on. But they are included there to help them with that. All right, thank you for taking this time out to go through this video with me. There have been some hiccups here with technology, but I hope that these videos are going to be successful or going to be helpful to make your life a success as a teacher or as a student, so that you can find ways to work smart and not just hard. Okay.